Okay, so let's take a look at what some of this will look like. So let's take a look at first at the concept 2.1. It's on page 29 if you want to follow along with me. Okay, so what we're going to do is we are going to start with a force. Okay, that is 800 newtons and it's 35 degrees from the negative x-axis. Okay, so we're just going to draw that force like this. Okay, we'll just call it F. That is equal to 800 newtons. It's been a while since I've used the tablet, so it's going to be a little interesting. Okay, and we want to break it up into X and Y parts. Okay, so, and we're going to use the parallelogram law. So here is our X. Oh, it didn't change color. Let's try that again. There we go. Okay, so there's our X piece. And we'll go back and we will draw our Y piece. Okay, so notice how F sub X is actually going in the negative direction. Okay, and F sub Y is going in the positive. So the one thing we forgot is our angle here. So our angle is actually 35 degrees. Okay. So when we break these up into components, what we're going to do is we are just going to do a very simple F sub X and F sub Y using sine and cosine. Okay, so let's worry about the X piece first. So I'm going to use that 35 degrees and I am just going to say F sub X is going to be equal to 800 newtons, and it is going to use cosine, so times the cosine of 35 degrees. And I know this is a negative, so I'm just going to, because it's going in the negative direction. Okay, so our X component, F sub X, when we do that math, is going to be 655 newtons. So negative 655 newtons. And I'm going to put a little I hat. That means it's going along the X direction. Okay, it's a vector with it's a unit vector with 655 units to it. Okay, let's do the Y. Okay, so F sub Y is going to equal 800 newtons. And that one is going to be times the sine of 35 degrees. So that means F sub Y is going to equal 459 newtons. Okay, so I can put this into that vector notation. So if I want to say vector F, well, let's go back and change color. Okay, so vector F, and I'm going to put a little arrow above this so we know we're talking about a vector. Okay, I can put this in this type of notation, a negative 655 I hat plus 459 j hat. And a lot of times we can list newtons in there, but you don't have to if you do that. It tells me that I'm talking about newtons for this particular force. Okay, so that's one thing that we can do. We can put the newtons in here too, okay, after each number, just like we have in the past. Okay, so that's what they call that component notation. Okay, so that is one way that we can write that force. Okay, let's look at another example. Okay, this is 2.2. Okay, all that it is, it involves a guy that pulls with a force of 300 newtons on a rope attached to the top of a building. It wants to know what the horizontal and vertical components of the force exerted by the rope at point A. Okay, so point A is up at the top of the building here. Okay, so our little drawing has a building here. Okay, and our little guy is pulling a rope like this. It is in tension. Okay, so, and we're going from point A. Point A is up here, according to our picture. So that means tension, it's pulling away from the point. Okay, and it's being pulled with 300 newtons of force. So 300 newtons. Okay, now we don't know the angle of this, but we do know some dimensions. Okay, so they tell us that this, from the horizontal distance here, okay, they tell us that that is 8 meters. Okay, and they tell us that the vertical distance is 6 meters. Okay, so what's really cool about these unit vectors is I can actually take this, okay, and find out what my unit vector is from those two measurements. Okay, so we already know that if I want to find the x component, right, that f, here, let's reset for a second here. F sub x, we know it's going to be 300 newtons times the cosine of that angle. So that angle in there. Okay, and we know that this one is going to be 300 newtons times the sine of theta. Okay. So we know that we could even just use tangent here, right, to find out what our theta is. We can use tangent and do opposite over adjacent. Okay, what they actually do in this example is that we know that the length of AB, this is what we call a standard triangle. We know that legs are 8 and 6. That means the hypotenuse is 10. Okay, so we already know from A to B down here to where a person is standing, right, that length is 10 meters. Okay, so by doing that, we can figure out what cosine theta is, right? So cosine theta would be adjacent over hypotenuse. Okay. Oh goodness, that's interesting. Okay. So cosine theta, we know is going to be adjacent over hypotenuse. That means 8 over 10. Okay, we can reduce that down and take a 2 out, and we can make it 4 over 5. Okay. Now, if we do the sine of theta, okay, that is going to equal to opposite over hypotenuse. So that's going to be 6 over 10. And we know that that can reduce, if I take a 2 out, 3 over 5. Okay, so what I can do is I can actually substitute in for cosine theta and sine theta there if I want to. Okay, so if we go down here to the cosine theta, okay, so this is going to equal 300 newtons times the cosine of theta, so times 4 over 5. Okay, and I'm going to end up with 240 newtons. Okay, then I'm going to do the same thing for the y. Well, similar. But this time I'm going to, sine theta is going to be 3/5. This is just like using similar triangles. Okay, so that 300 newtons times 3/5, we're going to get, and it's pointing down, so I'm going to get a negative 180 newtons. Okay, so one other way I can list this force, instead of just saying 300 newtons at that angle, right, I can also put it into that Cartesian vector notation, okay, where we just note the components. So I'm going to say force F is equal to 240 newtons I hat minus 180 newtons j hat. That just means I'm going 240 in the x and down 180 newtons in the y. Okay, so that is another way that we can figure out what our force components are. Okay, let's take a look at another one. Okay, so this one is going to be sample problem 2.3. We've got a combination of 4 forces that are acting on bolt A, and we want to determine the resultant. Okay, so I have, here's my point A, and I have my first force is 150 newtons going out at a positive 30 degrees with the x-axis. Okay, so this we'll call, this is 150 newtons, and its angle is 30 degrees with the horizontal. Okay, then F2, it shows an 80 Newton force going 20 degrees from the y-axis. Okay, so there's our force. It is 80 newtons. And we've got a 20 degrees in there. Okay, F3 is, lucky for us, is pointing straight down. Along the negative y-axis. That force has a magnitude of 110. And then we've got one more that is 100 newtons at a negative 15 degrees. Okay, and we will start right there on the next video.